So today we're going to look at the molar volume of gases. Okay, so before I explain what the molar volume is, it all is based on this one concept. Okay, so this one concept is 1 mole of all gases. Okay, now this is an important part, all gases. Okay, so 1 mole of all gases, and then obviously the next important part is at the same temperature and pressure. Okay, at the same temperature and pressure will have the same volume. Okay, and you need to know that. So we are looking at the molar volume of gases, and this only applies to gases. Okay, so if it's a solid or a liquid, we don't sort of include it. So 1 mole of all gases at the same temperature and pressure will have the same volume. Okay, so if we look at this, hopefully I can draw 3 almost identical circles. Okay, so let's say we've got 1 mole of O2, we've got 1 mole of N2, and we've got 1 mole of carbon dioxide. Okay, all of these, okay, they all occupy the same volume. Okay, that's what the circles are representing, the volume. Okay, so 1 mole of any gas occupy the same volume. Okay, now the definition of molar volume, this is one of these definitions that you sort of just need to know. Okay, so the volume occupied by 1 mole of any gas, again it has to be at the same temperature and pressure because that does make a difference. So at the same temperature and pressure is known as the molar volume. Okay, now let's go over that. So the volume occupied by 1 mole of any gas at the same temperature and pressure is known as the molar volume. So the molar volume is the volume of 1 mole of any gas. Okay, so as usual, what you need to do is you need to learn this. Okay, so let's highlight that. So the volume occupied by 1 mole of any gas at the same temperature and pressure, we call that the molar volume. Okay, I'll just highlight that as a different colour, the molar volume. Now this is just a wee bit extra, okay? Just to let you know, because it comes up in questions and it's good just to sort of understand what it means. So usually the temperature and pressure is 25 degrees Celsius and 1 atmospheric pressure respectively. Okay, usually it's 25 degrees Celsius and 1 atmospheric of pressure. Okay, this is known as the standard. Okay, the standard temperature and pressure, because 25 degrees Celsius, that's room temperature. Okay, this is known as the standard temperature and pressure, STP. So you might see that in questions. That's all that means. It's at 25 degrees Celsius, 1 atm. Okay, now let's move on. So this is going to be a bit of a shake up. There are 3 equations to work out the number of moles. Okay, now you know 2 of them. Okay, so the first one, nice and easy, the very first one you learned at Nat 5, M over GFM. Yeah, no excuse, you need to know that. It's in the data book, but you should know that off the top of your head. The next one is N equals CV, concentration times volume. Again, that 5, you know that, it's in the data booklet, but you need to memorise it. Now, I'm going to introduce you a brand new one, and it links in volume and it links in molar volume, okay? The number of moles equals V over Vm, okay? Now, you need to memorise that, because unfortunately, this one is not in the data book. Okay, it's not in the data booklet, so you need to memorise that off the top of your head. Okay, so V over Vm. Now, I'll explain what it means very quickly. So, V, as usual, V equals the volume, and it is the volume in litres, always has been. Okay, volume in litres. If it's in centimetres cubed, we divide it by 1,000 to get into litres. Vm, okay, is the molar volume. Okay, the molar volume. Now, the molar volume usually is 22.4 litres per mole. So what that means is that every gas, 1 mole of every gas takes up 22.4 litres. Okay, that's what that means. Now, that is at standard temperature and pressure. Okay, but the good thing is, it will be given to you in the question. Okay, but will be given in the question if needed. Okay, obviously if it asks you to work out the molar volume, it won't be given, but it will be given, and that's a sort of a trigger point for you. If you're given the molar volume, you know, okay, I'm going to have to use this equation one way or another. Okay? Now, the way I remember it, you don't really, this is just what I do, but if you think of sort of like a mountain, like that, yeah, or a pyramid, yeah, a human pyramid, you always have the sort of the bigger one at the bottom. Okay, so that's Vm. Okay, and then V, the smaller one, that's at the top. Okay, that's how I remember it. The bigger one, Vm, 2 letters at the bottom. The smaller one, 1 letter at the top. Okay, now, obviously you already know this, but you will need to be able to use all 3 equations. You will need to be able to use all 3 equations. Okay, now we hint, because what they can do is they can bring in molar volume in an excess question. They can bring it in. Okay, so you need to be aware, you need to be able to use all of them. So hint, if given mass, use obviously N equals M over GFM. Yeah. If given concentration, use N equals CV. Okay. If given molar volume, then obviously you would use N equals V over Vm. Okay, you also need to know how to manipulate each one. So if you want M, rearrange the equation. If you want C, you know, bring the V down. If you want V on its own, bring the Vm up. You need to know how to do all of that as well. Okay, right, let's move on. Right, so let's carry on. So since all gases take up the same volume at 1 mole, Okay, so 1 mole of all gases, remember, 1 mole of all gases have the same volume. Okay, so since all gases take up the same volume at 1 mole, then if a question asks, okay, if you get asked a question, what gas occupies the largest volume, okay, basically all you're after, what gas occupies the largest volume, whatever one has the most number of moles, that's going to be the largest volume, okay? So we can work this out by calculating number of moles. Now this might not make sense just yet, but the minute I start doing a question, it will click in, don't worry. So example, let's go for number 1. So 0.2 grams of hydrogen or 0.44 grams of carbon dioxide. Okay, so the question will ask what one has the largest volume. Now, all we need to do is calculate the number of moles. Now, hydrogen, it might not give you the formula, but you need to know that hydrogen is a diatomic element. Okay, and a lot of people make that mistake and they just put H. No, it's not H, it's H2. Okay, so I'll highlight that, H2. Okay, and just make a wee note here, diatomic. Okay, and remember to work out your diatomics from that 5 is H naught down. Okay, so obviously we could work out the GFM of that as being 2, and if we plug that in, we've been given a mass, so we use M over GFM, so that's 0.2 divided by 2, nice and easy, that is 0.1 moles. Okay, now split this up just to make it a wee bit clearer for you. So let's do carbon dioxide, and again same idea, if we do this, that's 32, that's 12, so it's got a GFM of 44. Again we're given a mass, so we would use M over GFM, so that's 0.44 grams divided by 44, and easy enough one to do, that's 0.01 moles. Okay, now if we look at these two, hydrogen has the bigger number of moles, so because it's got the bigger number of moles, that must mean it's got the bigger volume, because if they've got the same number of moles, yeah, if they've got 1 mole, it's the same volume. So because hydrogen's got more moles than carbon dioxide, hydrogen is going to have a larger volume. So let's write that down. So since hydrogen has more moles, then that occupies a greater volume. And that's it. That is it. It occupies a greater volume. Okay, so I'll do another example. Change the question ever so slightly. We like to do that. So, does 3.5 grams of nitrogen occupy the same volume of 4.0 grams of methane? And again, methane, you should know this, but it's CH4 at STP, so that's standard temperature and pressure. 25 degrees Celsius, 1 atm. Yeah. Right, so let's start this. So in nitrogen, again, you need to know, because you might not be given the formula, you need to know that nitrogen is again one of your diatomics, H naught down, M. So that is 28. Plug that into our, we'll be given a mass, so we use M over GFM. So that's 3.5 divided by 28, and what we're getting, we're getting 0.125 moles. Yeah? Now if I just split it up just so it's clearer, let's do the same for methane. So methane, CH4, that's 4, 12, 16. Yeah? We've been given a mass, so N equals M over GFM. Plug that in, so that's 4 divided by 16. Again, a nice wee easy one to do. 0.25 moles. Okay? So, does 3.5 grams of nitrogen occupy the same volume as 4 grams of methane? Because they've got different number of moles, no they don't. Okay? Methane has got more moles, okay? So that's going to have a greater volume, and that's it. Okay, that is it. So, since number of moles are different, spell that right, different, then they do not, okay, they do not occupy the same volume. They do not occupy the same volume. And again, the question never asked for this, obviously, but CH occupies larger volume since there are more moles. Okay? And that's it. That's it. So guys, just to sort of conclude that, so a wee conclusion. Higher number of moles equals a greater volume of gas. Okay? And that's it. That's our conclusion. Higher number of moles, greater volume of gas. Lower number of moles, a smaller volume of gas. That's it. Okay? Right. Now, what we're going to do, again, the best way to learn a calculation, in my opinion, is just to do it. So that's all we're going to do. We're going to do 4 calculations, each a wee bit different than the other, just to get you an idea of what's going on. So calculations involving molar volume. So I'll give you 4 questions and we'll see how we get on. So the first question, 4 grams of methane occupies 6 litres. Okay, and the question, what I want you to do is calculate the molar volume. Okay, so as we do with every calculation, the first thing that we do is we write what we know. Okay, so what do we know? Well, we know if we've got a mass of 4 grams. Yeah, we also know we've got a volume of 6 litres. That's all we know, and we're asked to calculate the molar volume. Okay, now what you have to get into the habit of doing, we need to look back at our 3 equations. Yeah, N equals M over GFM, N equals CV, and N equals V over VM. Yeah, now if we look at them, is there any we can use to calculate the number of moles? We can't calculate the number of moles using our new equation because we don't have the molar volume. We can't use N equals CV because we've got the volume but we don't have a concentration. However, we've got a mass. We can work out the GFM of everything because we've got a data book, so we can do that. So what we're going to do, okay, and I want you to just make a wee note here. This is a wee think And you do this with all these calculations, okay? What equation can I use to get N? Okay, that's your number of moles. Okay, so what equation can we use? So we split our page into 3. Okay, and as usual, the first one we calculate the number of moles. So we've got CH4 because it's methane, and let's work at the GFM. So that's 4, 12. So that's a GFM of 16. Yeah, and we're using N equals M over GFM. Okay, so the mass, we've got 4. The GFM 16, nice easy one, that is 0.25 moles. Okay, now we drag that into the middle and you'll see there's not a mole ratio. Okay, so it literally just goes in to the middle. Okay, we only get a mole ratio when we've got more than one reactant. We're only talking about one reactant here, one substance, so here it is. So 0.25 moles. Now in the last box, we always do what the question asks you to do. Now, our new equation is N equals V over Vm. We're after the molar volume. Now you need to rearrange. Okay, now it's up to you how you do it. You can do the whole change side, change sign, where you bring the Vm up, you would bring the N down, or you can use the triangle. There is a triangle for this. So V goes at the top, N goes at the bottom left, and Vm goes at the bottom right, and then whatever one you want, you cover up. So if you wanted N, that's V divided by Vm. If you wanted V, that would be N times Vm, and if you wanted Vm, that would be V over N. Okay, it's up to you how you do it, or even if you just memorize the equations, but you need to know how. Okay, so get Vm. So we covered Vm up, that would be V over N. So that is 6 divided, again bring the number of moles in, 6 divided by 0.25, and the molar volume is 24 litres per mole. Okay, you need to know the units as well, so that's litres per mole. Okay, because for every 1 mole, a gas is taking up 24 litres. So let's highlight that. 24 litres per mole. Right, let's do another question. Question 2. Calculate the volume of hydrogen gas made when 3.25 grams of zinc reacts with excess sulfuric acid. Okay, and like I said, you'd always be given, if it was this type of question, you'd always get given the molar volume. So take the molar volume of a gas to be 24 litres per mole. Okay, don't get confused with concentration where it's moles per litre, it's litres per mole. Right, this is the equation here. So Zn solid plus H2 SO4 aqueous, and that goes to Zn SO4 aqueous plus H2 gas. Okay? Right. Now, first things first, what do? We write what we know. What do we know from this question? Well, we know that we've got 3.25 grams of zinc, so that's our mass, 3.25 grams of zinc. What we're trying to work out, we're trying to calculate the volume of hydrogen, so V equals question mark, but we also know the molar volume is 24. So the molar volume is 24 litres per mole, okay? And remember what I said, this only applies to hydrogen because hydrogen is the only gas. Zinc's a solid, sulfuric acid is in solution, and zinc sulfate is in solution as well. So this only applies to hydrogen, the molar volume, because that's the only one that's a gas. Yeah? So, let's do what we normally do. So let's split our page into 3. Now this time, we do have a mole ratio. Yeah? And it's a mole ratio between zinc and hydrogen. Yeah? So this calculation is basically, it is a Nat 5 calculation, but we're adding a higher equation in. That's it. Okay, so this shouldn't feel sort of new to you. You should feel comfortable. The only new thing is this new equation. Okay, now the mole ratio between zinc and hydrogen is 1 to 1. Okay, so we start, zinc's on this side, hydrogen is on that side obviously. So zinc, we've been given a mass, so we use our N equals M over GFM. Okay, so that's 65.4, so N equals M over GFM, and that equals 3.25 divided by 65.4, and that is 0.0479 moles. Okay, pull that in, so that's 0.0479, that gives us 0.0479. Yeah, now all we need to do, our new equation, I'll do this a different time, you don't have to write this every single time, it's just until we get used to it, sorry. So our new equation is N equals V over Vm, okay, but the question is not asking for the number of moles because we've got that, it's asking for V, so we need to rearrange it. Now either use the triangle or use the whole change side, change sign. So in order to get V on its own, we need to bring the Vm up. So V equals N times Vm. Okay, V equals N times Vm, and then bring the number of moles across. So that's 0.0479 times 24, which is our molar volume, and that's given us 1.193 litres. And guys, that's it. Yeah, that's it. Doesn't really, to be honest, doesn't really get much harder than that. I'm going to do 2 more equations, two more questions, sorry, just to get you more practice on it. But yeah, it really doesn't change that much. So let's do this one. So calculate the mass of calcium carbonate required to form 2.8 litres of carbon dioxide in the equation below. Okay, now as usual you will get given the molar volume, so take the molar volume of a gas, yeah, always a gas, of a gas under conditions of the experiment. Okay, so the conditions could be, it could be 20 degrees Celsius, whatever, it doesn't really matter, but under conditions of the experiment to be 22.4 litres per mole. Okay, that's our question, and our equation, which you'll always be given, is obviously you've got calcium carbonate as a solid, so that's a base, adding that to hydrochloric acid and alkali, so of course we're getting a salt, calcium chloride, plus carbon dioxide because it's a carbonate, and we're getting water. Okay, now first things first, write what we know. So calculate the mass of calcium carbonate. Now you need to be able to recognise calcium carbonate, obviously is this one here, and carbon dioxide is the other one that the question talks about. So calculate the mass of calcium carbonate, so the mass equals a question mark, yeah. What else do we know required to form 2.8 litres of carbon dioxide? So we've made our volume is 2.8 litres, okay? And what else do we know? Well, we know the molar volume is 22.4 litres per mole. So that's what we know about this question. Now, let's split our page, and again, mole ratio goes in the middle. Mole ratio between what? Well, between calcium carbonate and carbon dioxide. Okay, and that is a simple 1-to-1. So calcium carbonate goes on the left and carbon dioxide goes on the right. Now, we've set up, let's do the question. Now, we always start with the side that we know most information about. Now, we don't know anything about that. We know the most information about carbon dioxide, so that's the side we're going to start on. We're not starting on the left, we're starting on the side that we have most information about, which is the carbon dioxide. Okay? Now, we've got a volume and we've got a molar volume, so that should be triggering you to be using this equation here. N equals V over Vm. If we sub in our values, our volume is 2.8, our molar volume is 22.4, and that equals 0.125 moles. Okay? Now, drag that into the middle, so that's 0.125, it's a 1-to-1, so that's 0.125, and we're working out the mass. Okay, so the mass equals N times GFM. Yeah, we know the number of moles is 0.125, but the GFM we need to work out. So we use the data booklet, 3 oxygens, that would be 48, carbon is 12, calcium is 40.1, so that is going to give us 100.1. Yeah? So if we plug that in, 0.125 times 100.1, we're going to get 12.5 grams, and that there is our answer. Yeah? See what I mean? These questions, they're straightforward, they're nothing new to how you already answer these types of questions. The only thing that's changing is that we're bringing in this new equation. That's it. Okay? Now our final question, question 4. Again, it's the same idea. The same idea. So calculate the volume of sulfur dioxide produced. Okay, so calculate the volume of sulfur dioxide produced when 200 centimetre cubed of sulfuric acid with a concentration 0.5 moles per litre is reacted with copper. Okay, and the molar volume of all gases, molar volume is 24 litres per mole. Okay, that's our question. Now the equation, Obviously, you're always given the equation. You would never be expected to come up with it on your own. So this is the equation here. So copper plus sulfuric acid is given as copper sulfate plus sulfur dioxide plus 2 moles of water. Okay, that's our equation there. Now, first things first, we'll write what we know. Okay? Now read the question. Calculate the volume of sulfur dioxide. So the volume, we don't know, because that's what we're calculating. However, sulfur dioxide, it is a gas. So the molar volume is 24 litres per mole. Okay, what else do we know? Calculate the volume of sulfur dioxide produced when 200 centimetre cubed. Okay, so volume equals 200 centimetre cubed. That's going to be 0.2 litres, because remember we need to divide by 1,000 to get that into litres, with a concentration of 0.5 moles per litre. Okay, that's it. So we know the volume, we know the concentration, and we're trying to work out the volume of sulfur dioxide. So let's split our page into 3. Mole ratio in the middle, and it's a mole ratio between sulfuric acid and sulfur dioxide, and it's a 2 to 1. Okay, so sulfuric acid is on the left and sulfur dioxide is on the right. Now, we always start with the one that we know the most information about. So we know the most information about the sulfuric acid, so we're starting on the left. Yeah, the side with the sulfuric acid. So we've got a concentration, we've got a volume. You need to know that we can use N equals CV. Okay, so that is 0.5 times 0.2, and we are going to get 0.1 moles. Okay, drag that into the middle. So 0.1, it's a 2 to 1 ratio, so we divide by 2 to get 0.05, and we are asked to work out the volume. Now remember, the equation, the new equation is N equals V over Vm. Okay, so V, yeah, to get V on its own, bring up the Vm. So V equals N times Vm. Bring the moles over, so that's 0.05 times 24. And that's going to give us a volume of 1.2 litres. And there you go. That is our brand new calculation. And it's not a hard one. Okay, it's the same sort of calculation that we've really been doing since Nat 5. We're just bringing in this new N equals V over Vm equation. Okay, so just to recap, you need to know the definition of molar volume. So the volume occupied by 1 mole of any gas at the same temperature and pressure is known as the molar volume. Okay, so that's the whole basis of this, is that 1 mole of all gases at the same temperature and pressure, obviously, will have the same volume regardless of the gas. Okay, you need to know your 3 equations, especially this one because it's not in the data booklet. Okay, and you also need to know that, well, suppose this conclusion here, the higher number of moles, the greater volume of gas. Okay, so if you've got 2 moles, that's going to have a greater volume than 1 mole. Yeah, 22.4 litres is going to have a greater volume than 20.4 litres. That's how it goes. Okay, and then after that, it was your calculation. You split your page into 3. Okay, we've been doing it from Nat 5. We're just bringing in something new. Okay, so I'll post up some questions on Teams, and that is us for today. Thank you.